We're going to be graphing our log functions. So log functions we said are the inverse of exponential functions. If I had 2 to the power of x, it would be the inverse of log base 2 of x. Now, if we were to graph 2 to the power of x, and we had this point 2, 4, the inverse of it, so the x's and y's flip for our log graph. So our point on our log graph would be 4, 2. So the x's become y's and the y's become x's. So they flip. Y's become x's, x's become y's. On the next page, we have our basic characteristics of log functions. So our typical log graph will have this shape here, where it's increasing. It's increasing when our base for our log is greater than 1. If our base was in between 0 and 1, so if it was some fraction or a decimal, it would be decreasing like this. So for our log graphs, the x-intercept is 1, and there is no y-intercept. This is the opposite from when we had exponential graphs. We had no x-intercept, and our y-intercept was 1. The y-axis, or x equals 0, is our vertical asymptote. So again, this is the opposite for exponential functions. Exponential functions, we had a horizontal asymptote. Here we have a vertical asymptote. So our vertical asymptote is going to go up and down. Now this will change, it'll shift if we are adding something inside of our parentheses now. So the log function reverses the domain and range of the exponential function. So before, our domain was all real numbers. Now our range is going to be all real numbers. So I'm going to write our basic characteristics for exponential and log. So in exponential, our domain was from -infinity to +infinity, all real numbers. For our log functions, our range is now going to be -infinity to +infinity, all real numbers. Our range in our exponential function was from 0 to infinity. Now our domain is going to be from 0 to infinity. However, we know that our range would change if we had a vertical shift. So vertical shift changed our range. Our domain is going to change if we have a horizontal shift. And then for our exponential functions, we had a horizontal asymptote and a y-intercept. For our log graphs, we're going to have a vertical asymptote and an x-intercept. Now our domain is going to be positive real numbers, and it's going to shift if we have a horizontal shift. To find that horizontal shift, we set the parentheses equal to 0. So our domain and our vertical asymptote are going to go hand in hand. They're going to be a similar value. We just set the parentheses equal to 0. So find the vertical asymptote, set the parentheses equal to 0. To find the x-intercept, we plug in 0 for y. So let's look at an example down here. I'm going to make one up. Let's say we had y equals log base 7 of x plus 4. Let's find our domain, range, vertical asymptote, and x-intercept. So starting with our range, what's our range going to be? All real numbers, -infinity to +infinity. Our domain and our vertical asymptote are going to go hand in hand. To find the domain and the vertical asymptote, we set whatever's in the parentheses equal to 0. So we have x plus 4 equals 0. So when we solve here, we get x equals what? negative 4. So our vertical asymptote is going to be x equals negative 4. How do you think we write that for our domain? Negative 4 to infinity. Perfect. And then we said for our x-intercept, we plug in 0 into the y. So we have 0 equals log base 7 of x plus 4. Now we talked about this in part 1, where our brains don't really compute log functions, but we do compute exponential functions. How would I put this into exponential form? So 7 to the power of 0, because we plugged in 0 to y. So 7 to the power of 0 equals x plus 4. Now from here, we can just solve for x. What's 7 to the power of 0? 1 equals x plus 4. Subtract 4 on both sides. So x equals what? Negative 3. So we have negative 3 comma 0 for our x-intercept. If I were to graph this, I would shift my horizontal or my vertical asymptote to the left 4 to negative 4. And then our x-intercept is negative 3, 0, so we'd have a point there. And because our base is greater than 1, we're going to have growth. We're going to be increasing, so our graph will look like this. Right, next we have transformations for our log functions. These are the same transformations we have for exponential functions. It's just being applied to a log now. So our parent function changed. When we add or subtract something on the outside, we have a vertical shift. So if we're adding on the outside, we move up. If we're subtracting on the outside, we go down. Horizontal translations happen when we add or subtract on the inside. So adding on the inside or adding directly to x, we go to the left. Subtracting directly to x, we go to the right. Now remember, horizontal translations will change the vertical asymptote and the domain. Reflections happen when we multiply by a negative. So if we multiply by a negative on the outside, it's a reflection on the x-axis. If we multiply by a negative directly to x on the inside, it's a reflection on the y-axis. And then if we multiply by a number, so by a coefficient on the outside, that would be a vertical stretch or shrink. If it's greater than 1, it's a stretch. If it's in between 0 and 1, it's a vertical shrink. If it's happening directly to x, it's the opposite. So if it's greater than 1, it's a horizontal shrink. If it's in between 0 and 1, it's a horizontal stretch. So example 7, we want to graph 3 to the power of x and log base 3 of x. So let's start by graphing our exponential function. I'm going to graph it the same way we did in part 1, where we plot values for x, get our y values, and that'll give us our points. So some good numbers to plug into x would be negative 1, 0, and 1. So I'm plugging it into my exponential function here. So 3 to the power of negative 1 would be what? One-third, 1 over 3, perfect. So negative 1 comma 1/3. So I'm going to go to the left to negative 1, up 1/3. Then when we plug in 0, 3 to the power of 0 is what? 1. So we have 0 comma 1. So I'm going to stay at 0, go up 1. And then when we plug in 1, 3 to the power of 1 is 3. So 1 comma 3. Let's go to the right 1, up 3. So this is our exponential graph. Now our log graph, when we have the same base, it's going to have those same points, but the x and the y's are going to flip. So for our log graph, the x's and y's just flips position. So my x now becomes the y, and the y becomes the x. So our first point is going to be 1/3 comma negative 1. So I'm going to go to the right 1/3 and down to negative 1. Our next point is going to be 1 comma 0. So we go to the right 1, stay at 0. And our next point is going to be 3 comma 1. So we go to the right 3 and up 1. So this is going to be our graph here. the inverse of our exponential graph. So the x's and y's just flip. Let's find all of our important information here. Let's find our domain, range, the x-intercept, and the vertical asymptote. What would our range be? Negative infinity to positive infinity, always negative infinity to positive infinity for our log functions. Our domain and our x-intercept go hand in hand. These are going to be the same value. What do we do to find the domain or the x-intercept? We set the parentheses equal to 0. Here we don't have parentheses because it's just x. We would just say x equals 0. Sorry, domain and vertical asymptote. Our vertical asymptote would be x equals 0, and domain would be from 0 to infinity. So there is our vertical asymptote at 0. How would we find the x-intercept? Let's set y equal to 0 and then put it into exponential form to solve. So 0 equals log base 3 of x. Our base would be 3. What's our exponent? 0 equals x. 3 to the power of 0 is, so 1 equals x. So our x-intercept would be 1, 0, which would be this point here. All right. In example 8, we want to use the transformations to graph our function. So we just graphed log base 3 of x, where we had these 3 points here. So our graph looked like this. Let's apply our transformations to this. So we start with what's happening directly to x. When we subtract 1 on the inside, which direction does that move our graph? If we subtract 1 on the inside, to the right. So we're moving to the right one. So all 3 of our points, we're going to shift it to the right one. So our graph now looks like this. And then when we multiply by a negative, what does that do to our graph? It flips it. It's a reflection on which axis? It's a negative on the outside. The x-axis. Outside is the x-axis. So this is our x-axis here. We're flipping the teal graph that we have now along the x-axis. So everything below my x-axis is now going to be above. Everything above my x-axis is going to be below. So our points are just going to flip along the x-axis there. So our graph looks like this. Because we just flipped the teal graph. It should look a little bit more like that, but. So our graph would be the pink one. So let's find all of our important information now. Let's find our domain, range, our vertical asymptote, and x-intercept. Start with the range. What would our range be? Negative infinity to positive infinity, always for your log graphs. How would we find the domain and the vertical asymptote? Domain and vertical asymptote go hand in hand. How would we find the domain and vertical asymptote? We set whatever's in the parentheses equal to 0. So x minus 1 equals 0. So x would equal 1. So our vertical asymptote would be x equals 1. So that would be our vertical asymptote. And our domain would be from 1 to infinity. And then lastly, how do we find the x-intercept? Set y to 0. So we plug in 0 into our y. So 0 equals negative log base 3 of x minus 1. Before we put this into exponential form, we got to get the log all by itself. So what should I do first? We divide both sides by -1, so it just makes this 0 equals log base 3 of x minus 1. Now what can we do to solve? Put it into exponential form. So what's our base? 3 to the power of 0 equals x minus 1. What's 3 to the power of 0? 1 equals x minus 1. Add 1 to both sides. So 2 equals x. So our x-intercept would be 2, 0, which would be this point that we have here. So you can find all of your information first and then put it on the graph. But it helps to know which way your transformations move your graph. What are the transformations doing to shift it or to flip it? Any questions here? Let's do the next one. So here we have log base 4 of x minus 5. So let's find all of our important things. Let's find our domain, range, vertical asymptote, and x-intercept. Start with the range. What would our range be? -infinity to positive infinity, all real numbers. Domain and vertical asymptote go hand in hand. What would we do to find these? We set the parentheses equal to 0. So x minus 5 equals 0. So x would equal what? Positive 5. So on my graph, I'm going to go to the right 5 and put our vertical asymptote there. So our vertical asymptote would be x equals 5. What would our domain be? 5 to infinity, perfect. And then lastly, let's find our x-intercept. What do we do to find the x-intercept? Set y to 0, so we're going to make f of x 0. So 0 equals log base 4 of x minus 5. Let's put this into exponential form to solve. So we have 4 to the power of what? 0 equals x minus 5. What's 4 to the power of 0? 1 equals x minus 5. Add 5 to move it to the other side. X equals 6. So our x-intercept would be 6, 0. So I'm going to go to the right 6, stay at 0, put our point there. Now, are we going to be increasing or decreasing? Does our graph have growth or decay? How do we know that? Our base is greater than 1, so we're going to have growth. Our graph is going to be increasing. So we're going to start close to our asymptote, and we're going to be increasing like this. Next page talks about natural logs. We talked about this a little bit in part 1. Our natural log is just log base e. So log base e is ln. So if it helps you when you see ln, change it to be log base e if you want. But just know, anytime you see ln, it's a log. It's just a specific type of log. It is log with the base of e. So in the last example, example 12, we're going to be graphing an ln function. So same thing, we want to find our domain, range, vertical asymptote, and x-intercept. So we're going to do the same thing we were doing in the last one. Let's start with our range. What's our range going to be? All real numbers, -infinity to positive infinity. Domain and vertical asymptote go hand in hand. What do we do to find these? Set the parentheses equal to 0. So x equals what? 3. So our vertical asymptote would be x equals 3. What's our domain? 3 to infinity. Now, your domain most of the time will be 3 to infinity unless you have a reflection on the y-axis where it flips, and then your graph's going to go to -infinity. So just pay attention to that. So we're going to go to the right 3, put our vertical asymptote. For our x-intercept, what should we do? Yes, and we're going to plug in 0 into y. So we have 0 equals ln of x minus 3. Now we want to put this into exponential form, so it might help us to change the ln back to a log. Log with what base? E. Because once we have it in our log form, we can do the same steps to put it into exponential function. What's our base? To the power of 0 equals x minus 3. What's e to the power of 0? 1 equals x minus 3. Add 3 to move it to the other side. So x equals 4. So our x-intercept would be 4, comma 0. So we're going to go to the right 4, stay at 0. Now, is our graph going to have growth or decay? Is it going to be increasing or decreasing? Why do you think growth? Because e is greater than 1. ln is the same thing as saying log base e, and e we know is what value-ish? 2.7-ish, about that. So it's greater than 1, so we're going to have exponential growth. So our graph will look like this. Well, not exponential growth, but it's growth with the log. So it's increasing. If your base is greater than 1, it's going to be increasing.